In the following exercises, use direct substitution to show that each limit leads to the indeterminate form 0 over 0. Then evaluate the limit. Enter only the limit. Okay. So when approaching any limit, the first thing you should do is just plug in the limit value. So if I plugged in the limit value here, that would be 3 squared minus 9 over 3 minus 9, which is 9 minus 9, or 0. Whoops, I don't know why I put a 9 there, sorry. Over 3 minus 3, which is also 0. And so the value of this limit is indeterminate. Now, that can mean a couple of things. One is you could probably do some algebra in order to rewrite this function so that you can continue getting the answer after performing some algebra. But now that we know L'Hopital's rule, we know it means another thing as well. It means that we could evaluate the limit by taking the derivative of the numerator and denominator and use L'Hopital's rule. So this would be 2x over 1. And now if I plug in the limit value of 3, that would be 6 over 1, which is 6. We didn't have to do any algebra, and we got the answer fairly quickly. We absolutely could have done some algebra, so an alternative is that I could have done limit as x goes to 3. The numerator would factor into x plus 3 times x minus 3, which shares a common factor with the denominator that we can cancel out. And then at that point, if I plug in 3, then I have 3 plus 3, which is 6. L'Hopital's rule, as long as you result in this 0 over 0 form, you are fully welcome to use L'Hopital's rule to evaluate your limits and come up with your answers that way.